Hello, guys. Today we'll be doing the EDA, which is exploratory data analysis. As you can see here, it's going to be module number 2. All right, we have finished module number 1. This is module number 2. And just as a reminder, so we're going to have 10 modules. Okay, it's going to be like a data science bootcamp to some extent. All right. So if you follow step by step what I'm doing here, you're going to be very comfortable later on to apply for a junior, for instance, or data scientist job. So the agenda of today is going to be just an introduction to EDA. The EDA is all about the processing the data, such as cleaning the data, profiling the data. I'm going to explain all these terms here. Data cleaning and profiling is exactly the process, especially the data profiling, is the process of examining and analyzing data sets to understand the structure, to understand the content, and the quality of the data. Okay. Then we're going to be assessing the data quality. What does it mean? Is to refer to the conditions of data, which determines its ability to serve its intended purpose effectively. Okay. And data rejection and imputation is data rejection is going to be rejected, is going to be deleted. It refers to the process of identifying and discarding data that does not meet certain predefined criteria of quality standards. Then we'll be doing exploring and visualizing the data, both the type of data we have. We're going to have a continuous data. I'm going to have the categorical data. And I'm going to see exactly how to plot both cases. Where does data come from? We need to understand where the data comes from. If you work for a company, for instance, they're going to provide you with the data, and the data is not going to be very clean. You're going to have raw data to some extent. You're going to have a lot of missing values, not plotting, nothing. Data may be an Excel file, maybe from a database, maybe from a website, maybe from feeds, and so on. Now we're going to see first, where does data come from? First of all, they're going to come from databases. We have many databases around here in the world, and we have Microsoft database, we have Oracle database, we have the database on the cloud, we have data marts, which is a subset of the warehousing databases, repository. We have transaction system, for instance, the cloud, we transact, there's a lot of transaction between yourself and the cloud. So data in motion. We have the mainframe, which is quite a node where the database can sit. We have the Hadoop, which is a distributed file system, for instance. And the Hadoop, it manages the storage of large amount of data for application. For instance, if you have the big data, pardon me, so Hadoop is the best way to store your data. We have the APIs, for instance, with the application programming interface, which this one is going to sit on your, maybe on your desktop. You're going to interact with the cloud, okay, and some of the data will be transferring in and out. We have the scanned documents. It's data too. We have data from website. It can be posts, it can be conversations, it can be web scrapers, data scrap from the web, for instance. We have subscribe feeds, like the news is a data type of data. The IoT is a data, and the IoT, these are a physical object where devices such as vehicles, appliances, and other items, for instance, embedded with sensors, software, and other technology that enable to connect and exchange data with other devices and systems over the internet. Okay, we have also other data such as images, part of the multimedia host. We have videos, we have audio, and we have lot of data and so on. Okay, so the data we are surrounded by data. Once you access the internet, will be, whether you like it or not, you'll be interacting with data. When you click on something, there's data coming from the remote server, for instance. It's come to, you're going to see it. When you search for something, it's exactly the same. So dealing with data is part of your daily work, if you are in a company or from home and so on. Okay, and this is just an example here. Some of the access to the data. This is a big, huge mart of data here. You can access all these data in the world. You can just click on this and you're going to see exactly what is all about here, the names of the repositories or the database and so on, where you can access some of the data. We have also open data. It's open to anyone from Data Hub, from datahub.io, from the World Health Organization. You have access to some of the data from the government, data.gov, European Union Open Data Portal, again, from Amazon Web Services, public data sets, you can access that. It's because it's public, it's private. When you see something public, you can access it, you can play with it and so on. But with something with private, it's illegal. Don't touch it, okay? You have the UCI, we have here, it's an archive, ICU or UCI.edu, you have a lot of data here. So for instance, if you are interested at one stage in your life to do one of the projects and you are looking for data to clean data, to plot and so on, probably UCI is the best place to look for data. There's plenty of data there, plenty of data. What does data look like? We have many different types of data. We have the database in tables, we have reports and extracts, we have spreadsheets and workbooks from Excel, for instance, and this one can be from Excel, it can be from a database for the tables. We have structured and semi-structured files. Okay, we have streams of data. We have the encoded file, for instance, and the encoded files are files that have been transformed into different formats using an encoding algorithm. This transformation can be for various purposes, including data compression, security, and compatibility. This is some of the structured data. What does it mean? We have the relational database from the database. We have rows and columns. We have SQL. All this is structured data. And you can see here the application here of this, where to apply exactly, where to get exactly the data from RDFMS, from RDF, from the ERP systems, from a data warehousing. These, all of them are structured databases, okay, or structured data. The semi-structured here, it's an HTML, XML, JSON files, okay, and this one can be server logs, sensor output, and so on. And the rest here, it can be unstructured data, which can be a binary and characters and so on. And this one is it's going to be the NoSQL. We're going to see this. What does it mean? NoSQL. It's not the opposite of SQL. It's NoSQL. We have the videos, we have the audios, we have the audios, we have the social media, etc. Okay, and here we can see exactly the type of database, the data we have, the unstructured, semi-structured, and the structured data. Again, we repeat here, it's part of the RDBMS or relational database, and this one is part of the organized by meta tags, and this one can be exactly the data lex. All right, that's part of the unstructured data here, which is this ones. Okay, so looking for data it's huge, and we have a lot of data, and the different type of data we have, as I mentioned earlier. It can be structured, it can be semi-structured, or it can be unstructured data. It depends what sort of data do you have, and this data has to be analyzed at one stage. Okay, especially at the beginning when we receive data. First of all, get the data and try to have a look exactly what does it look like. Is it going to be structured like tables? Very simple. Straight away, is always going to be semi-structured like server logs, sensor outputs, or it's going to be unstructured data. It's going to be, for instance, NoSQL, the videos, the audios, and social media, for instance, the chat, the online forums, etc. Okay, this is exactly the type of data, the different types of data you could be facing in your career. And what is exactly the exploratory data analysis. In a short thing, the exploratory data analysis is all about pre-processing and processing the data, which is an approach to analyze data using visual techniques, for instance. It is used to discover trends, patterns, and to check assumptions with the help of statistical summary and graphical representation, dealing with missing values and outliers. So it's the whole thing, okay? So before you process the data with an algorithm, for instance, what you need to have to do is to, first of all, have a look at the data, see what does it look like, it is structured, unstructured, or and so on, and then get into the work, which is plotting, cleaning, dealing with the missing values and outliers. Okay, and this is exactly the data science pipelines. You start first with the raw data here, and all these phases here, what you see here, it depends on the type of data you have. For instance, you have univariate data with one variable. We have multivariate data, which has multivariable with x is a function of y and z, for instance. Or you have a lot of stuff here, and at the end, you're going to process the data here, and at the end, you're going to clean them and present them to the algorithm. That's the data science pipeline. How do we make a data set usable? So the process is to do the wrangling, profiling, and cleaning the data, the munging, and then move on, okay? The wrangling of the data, sourcing, loading, and pre-cleaning the data so we can see what it really looks like and fixing the critical issues, okay? And then we do the profiling and cleaning, understanding the essential characteristic of the data, applying primary transformation to confer context and meanings, and the last one is to implementing strategies for missing and invalid data. You're gonna have, be sure when you tackle a project and will receive data, the data you're gonna receive is not going to be clean, okay? It's not perfect data. Part of your job, and this is this phase, which is the EDA, is going to take you probably 70 to 80% of your work, okay? Once this is done, the modeling part is very easy, okay? The modeling part, the tuning, the model, getting the model and so on, that's the easiest part. But the most difficult part is to make sure for the data you're gonna send to the, you're gonna process and pre-process and process. When it's finished, you're gonna send to the model. The model cannot accept wrong data. Okay, it's going to give you wrong results. Okay, or it can't accept some of the outliers, or it probably cannot accept some missing values and so on. Okay, it depends what type of model you're gonna have. Okay, so this process of wrangling, profiling, cleaning, munging, reshaping the data to prepare it for analysis, and so on, it's very, very important. So in practice, to some extent, there are the three common tasks involved in the wrangling phase here. And the wrangling phase here is going to be the cleaning, transformation of the data, and data enrichment. Okay, and the data cleaning can be renaming some essential data cleaning tasks. To must include the following, such as renaming the data, sorting and reordering the data, for instance, from top to bottom, from bottom to top. Data type conversion, you can convert the data, convert the data into different formats and so on. Handling duplicate data, it's not acceptable too. If there's a duplicate of your data, by mistake, those who have entered the data, they have added twice. Addressing missing and invalid values or invalid data, filtering to the desired subset of data. So very important here. This phase here is going to take you probably 40 to 50% of your time. Once you have done this, the 20% or the 30% left is going to be on the plotting part. It depends what you want to plot. Okay, it's this is very important here. This is one of the examples here of the data we're going to have. We're going to have, this is the data that comes from the Titanic. I'm sure you guys, you have heard about the Titanic. Maybe you have heard about the film, about the film. But the real data we have here is we're going to have the different names here of the different variable description of the data we're going to have with the Titanic here. We have the P class, where how many people survived, 0 survived, yes, 0 not survived, yes, they survived, the name of people, the sort male, female, children, age, number of siblings and spouses on board, number of parents, which is parked like here, okay, and the cabin number, this one, embarked port, boat, etc. So some of them are useful, some are not useful. The P class is very important. Survival, that's what we would like to predict, okay, because once you have the data, how many survived, how many did not survive. That's the prediction, okay, based. The name, we don't care. The sex is very important, male and female. The age is very important for the predictions. The number of siblings, the parent or not, yes. We don't care about the ticket, not very important. The ticket is going to tell you nothing about how many people is going to survive. The fare, yes, because it's going to tell you about the passenger fare. Why exactly? It's going to tell you if it is first class, the second class, third class, and so on. The cabin, yes. The cabin number, we don't care about it. The embarked port, some of people, they embarked in the UK or in Ireland, it depends where, not very important. The boat life, boat, not very important. The body identification number, not very important. And the home address is not very important. And those who are very important when it comes to the variable description, we put them, all of them here. And all we're gonna play with all these data from the Titanic, which is P class, sex, age, the sibling, parent, the fare, to predict the survived. Okay, here in this case here, for this male, it did not survive. For this female, survived, survived, not survived, etc. As you can see here, probably they give a lot of priorities to female here with the children. You see with the siblings here, and to go first on the safety boat. All right. So here, these are the data. All right. These are the data after cleaning them and so on. And then what you can do here, we're going to transpose the data. What does it transpose the data? We're going to change the data from this to this. Okay. What does it mean? Well, the P class, sex, and age is going to be in the column here. All right. Yeah, in the column here. And this one is going to be the index. That's the index here. That's transposing the data. Okay. As you can see, keep this in mind, guys, that data, when it is in the table, is very nice. And then it is a matrix. I talked to you about this before. What you can see here, you can see like, it looks like a matrix here. And once you have a matrix here, you can transpose it. And transposing this matrix here is going to give you the P class, sex, age. Instead of this way, it's going to be that way. Okay. And the rest is going to be exactly the same. Okay. And this is are the variable descriptions of all these columns here. Okay. And this one in Python, what we're going to do here, in Python here, we're going to do here, first of all, the df data dot capital T. That's transpose. Okay. And this one, we're going to do exactly the describe. And the describe is going to give me the descriptive statistics of this data. What does it mean? It's going to give me the count of the data. It's going to give me the mean for each column. It's going to give me the standard deviation, the minimum value in that column, the minimum value, for instance, here. For instance, in age, the mean is 29.69 years. Okay. And the minimum value is 0.42. All right. What does it mean? It's a baby. Okay. That's the 25%. Remember those 25%, the 50%, and the 75%. And this is the maximum value of age, which is an old man, okay, 80 years old. And this standard deviation, I repeat again, it's the deviation from the mean. Okay, you have the mean, you have the standard deviation from the mean. That's exactly very important, this value here. We're going to talk about this later on. We're going to talk about this later on. And this one, we're going to have P class, age, siblings, park, fare, and survive. All right, this is an example how we can with the data in perspective. And when sometimes in the data, you can see something like NaN. What does it mean? That data, if there's an NaN here, what does it mean here? The data is not available, not a number, all right? It's not a number, or it's not available, and we have to calculate it, okay? We can calculate this with this following the some of the examples I'm going to show you. And the data we'll be dealing with most of the time, the data can be a CSV file, or can be Excel file, or can be an SQL table, can be JSON, can be HTML, Stata, clipboard, Pico, MGPack, etc., etc. But in our case, we'll be dealing most of the time with CV, with Excel, and probably some of the example will be with SQL, JSON, and HTML. Okay, this is exactly an example. Okay, the reading text file, for instance. If you want to read text file, okay, if you want to read text file, you're going to read with open the name of the data, read as file, and put the name of the file here. It's exactly the same thing to some extent, but the code is going to be quite different here for the text file. Here for file line by line. Here for RCV file, which is this one, and here is going to be the from pandas. And from pandas, if I'm going to use the pandas for the RCV file, for instance, we're going to import first pandas as PD. That's we're going to import the library, very important. If we don't import the library here, this one is going to display an error, okay? And this one is going to be df, the name of the data, of the data, of the table, or the data. PD is pandas. PD comes from this one here. I'm going to explain this later. Dot read CSV here, and this is the name of the data file, okay? It's name of data file, like for instance here, the name of data file is going to be titanic.csv, okay? So this is some of the extension of the data we'll be dealing with, okay? But most of the time, as I said before, this data will be dealing with the CSV, with Excel, not with HDF, because this one is going to be Cassandra, not at this stage. That's the Unix part of it, and so on. We'll be dealing maybe with some of the SQL examples, and JSON, HTML. It's especially if you're dealing with data on the web, for instance, a lot of data will be reading from the web. It's going to be in HTML, okay, or maybe it's going to be in JSON, okay. But if you're dealing with a table, it's going to be our CV, Excel, or it's going to be the SQL from any database, whether Microsoft, Oracle, or just to name it, okay? And this is the process. Where does the EDA fit? The EDA is, at this stage here, that's the whole process to some extent. That's the whole process here. And the EDA is going to fit here. That's the EDA, the exploratory data analysis, wrangling, cleaning, profiling, managing. And this one is not really part of the EDA, but this one is the model prediction. When this one is finished and the data is clean here, so we send all the data here to be modeled. Okay, so we have to select the model here, we have to predict, and we have to evaluate. Okay, if it is a good model or if it is a bad model, it depends. And then we have to plot the data. We can plot the data even here. We can plot the data here. The visualization here, we can do it here. And the deploy, we deploy once we are happy with, for instance, we have here 90% of the accuracy of the model, so we can deploy it. We can deploy it in a large scale. At this stage here, we have a small scale, okay, of the data, but here is going to be a small scale, not small scale of the data, but small scale analysis. But here is going to be deployed to a large scale. What does it mean, deployed to a large scale? So the users will be interacting with the model. So the user will be sitting here and interacting exactly with the model, which has been developed by data scientists. So once the model is here, we have done it, we're happy with it, okay? And then we're gonna deploy it. deploy it for the large scale. At the end of the day, you're going to see here the users is deployed already. We're going to see the users here sitting here. I'm going to write it down for you guys to understand exactly once. Okay, now the next step here, we're going to have the users here. Okay, and they have the laptops here, and they have got the application here, and application apps. Okay, they're going to interact with the application designed at this stage here. All right, that's very important here. All right, so it's yeah. All right. So the next phase is going to be what? It's going to be, so we have talked about the cleaning, profiling, the quality of the data, rejection of the data. If it is bad, imputation of the data, we get rid of it. Sometimes you have you have a lot of columns nearly empty, for instance, or some of the rows nearly empty. What to do with it? This is a very important question here. It depends on sort of what sort of skills you need. At the end of the day, when you have a lot, some of the data, you reject some of the data. Some of the data are outside the boundaries of, let's give you an example here. You have age, right? You have age here. And you have age, you have 20, 31, blah, blah, blah. And you have here 200, all right? Then in this case here, we need to get rid of this, okay? Because it is an outlier. Okay, guys, and sometimes yes, if you have, maybe you're gonna have one, maybe two, maybe three, depends. Again, here, this is regarding a column, and sometimes we have for the rows here, you have some of the rows that quite missing. Okay, how to do with that? How to deal with that? Okay, but most of the time we have these. Well, you have these, but it's not really quite common. We have one row missing a lot of data. It's not quite common. What is common, you have one column. Yeah, what is common, it was, you have one column here, and this is quite, you can find a lot of data missing here, okay? So the data, we're gonna do some data cleaning, preparing it for analysis. For the data cleaning, we're gonna do the formatting, the conversion, dirty data, we're going to get rid of it. The profiling with data type, we need to understand the data type and data range, especially when it comes to the continuous and in categories. All right, we're gonna discuss this more and more and more. Okay, and this is the cycle of the data profiling and the data cleaning. All right, this is just a cycle. We start by the raw data, and we go all the cycle here, summarize the data fix missing values, data fix missing and valid values, summarize, etc. Once this is done here, then the next step is going to be the visualization. We'll visualize it, okay? Sorry, guys. That's the type of data we'll be facing from database. We're gonna have flat files, HFS, okay, from database here. We're gonna have spreadsheets. We talked about this before. We're gonna talk about JSON, XML, HTML. We're gonna have the API. We're gonna have the stream of data like the feed, the IoT, web scraping. Then we have a website here, and this website, it has a lot of data. We're gonna scrap it. This is the process called scrapping. Okay, it's like scrapping the data, taking the data from the website, for instance, for analysis. You can have a text document such as scan text and so on. So, guys, this is exactly what it's all about when it comes to the data. And we have some of the formats of the data. It depends on the time, for instance, or the date of the day. You have the day, month, year. This is one standard. The second standard is this, month, day, year. Here, day, for instance, it's going to be 07. All right, month is going to be 12. Okay, it's going to be 12 in the year 2024, year 4 for numbers here, etc. We have this one too. Okay, it's another format, date format. Okay, and we have the time. We have this here. It's a date format here. We have the time format here is AM or PM in the morning or the afternoon. Okay, or you can, it depends on the time zone, etc., etc. So we can format at the same time the daytime, the date and time. Okay, so we can format the date and time to a string called date times. We're going to show you this later on. Okay, that's very important. You can have like some of the data which can be in binary, octal, hexadecimal data, which is in base 2 or base 8. That's base 2, that's base 8, and that's base 16. Now, if you want to get change, for instance, give you an example. If you want to change 12, okay, that's what here we're going to change it to octal, which is 8. Okay, number. How to change it? We're going to divide it 12 by 8. And we're going to have the 1 here. It's going to be equal to 1. And the remainder is going to be 4. And then we divide what is left here from 1. We're going to divide this by 8 again. And we have the quotient is going to be 0. And the remainder is going to be 1. At the end of the day, we're going to have the remainders read from bottom to top are 1 and 8, 1 and 4, sorry. Here it's 1. Yeah, okay, here it's 1. Sorry, here it's 1, here it's going to be 4. Okay, 1 and 4. And this one is so, and therefore, the decimal number of 12, which is the octal number of 12, is going to be 14. Okay, so you can do this exercise by yourself. All right. Then the data cleaning and profiling again. I'll give you some of the example. There's drop rows. We can do that. We can replace with NA, not available, or it's empty. We can impute the values, for instance. We can impute them, get rid of those data, or we can fill them with a model called ffill or bfill. We're gonna see this. What does it mean? Bfill, or we can fill that data. If the data is missing somewhere, you have data here and here is missing, we have data here. So this one, what is missing here, we can replace it with the mean of this column, okay? Or we can replace it with the median or the mode, etc. of the entire column, all right? Or we can have the nearest neighbors. For instance, the nearest neighbors here, it can be with ffill or bfill. This one is missing, and this one is 20, and this one is 41, for instance. So this one, before fill, the before fill is going to be this one. So this one is going, if we implement before fill, this one is going to be 41. Okay, and if you implement ffill, we're going to implement exactly this one is going to be 20 here. Okay, we don't want the data to be empty here. Okay, that's, we're going to see some of the example here. Just one example here. We have all the passengers here. We have all the features. We call them these are the features. All right, and the lates. What do we want to predict here? We're going to no. This one is going to be the target. That's what we want to predict, and the rest here is going to be the features. Okay, so here we have 177 data missing here. Okay, and here in the cabinet we have 687 missing, for instance. But the sum, it's quite a lot. But again, it's yeah, it's quite a lot. Okay, and then here we're gonna get rid of the missing values here using drop NA. We're gonna drop all the data which does not have, which are missing. This one is 687, this one is 177, and this one is going to be 2. So we dropped all of them to 0. Okay, as you can see here, the cabinet is 0. Sorry, yeah, the cabinet is 0. The unbacked is going to be 0, 0, and A is going to be 0. So we dropped all the missing values. We have to be very careful here. Okay, well, I'm gonna teach you some of the tricks or some of the tips. We don't want to drop everything. Okay, and here we can replace, for instance, this one by 0. We have these missing values, and it can be replaced by the cabin by 0 here, for instance, if it is too high. Okay, so we can replace that. These are the commands, right? And here is going to be 0 here. Okay, that's a 0 here. All right, so what you can do here, you can drop the rows, you can replace with NA, we can impute the values, we can use F field, B field, with a mean, with a median, or before and after. So it's going to be quite interesting here. Be very careful. In the whole EDA, which includes the cleaning, profiling, and visualization. And this one is 80% of the work. It's going to be here. Okay. The rest, 20% here, is going to be the modeling, tuning, and deployment. Okay. That's the easier part, guys. That's the easier part. Okay. When you reach this one, you're gonna see with the modeling part is going to be a lot easier. It's going to be very, very easy. Okay. But then we need to put some work exactly where? With the EDA. Okay, keep this in mind. This is just an example how to replace it. For instance, we have to example of missing values. We have to import the pandas. Pandas is very important when you deal with the data. Always you have pandas. If you don't use pandas here, if you use pandas here, you're going to have an error here. Errors. No pandas. No pandas. Okay. So this is just an example of data. We have A, B, C. That's a column. That's data A equal to 1, 2, none, there is nothing, an empty 1, 4 and 5, B equal 5, none, 3, none, 1, and C equal to none, 2, 3, 4, 5. As you can see, we have few missing values here, none, okay? And this is when you put DF here, we put it in a data frame, it's going to display what you have here into a table. That's what it is. Okay, that's data frame. That's probably A, that's B, and that's C. And you have the data here. And then we're going to replace all what is missing here with the mean. So the mean of A, DF, that's DF, which is in the DF, that's called DF. DFA dot mean is going to calculate exactly the mean of A here, which is 5 and 4, 9, 9 and 3, 12. 12 divided by 1, 2, 3, 4 equal 3. Okay, and then we have here, that's the 3. It has been replaced by the minimum, by the average or the mean. Here exactly the same. Here exactly the same. 5, 8, 9 divided by 3 is going to be 3. All right, and you can see here is going to be 3. Okay, that's 3 here, and that's 3 here because we have 2 missing values here. Okay, and the last one is going to be 9, 11, 14, and 14 divided by 4 is going to be 3.5, which is that one will be replaced by 3.5 here. All right, and the rest is going to be 2, 3, 4, 5. That's 2, 3, 4, 5. Okay, and here we will ask fill the missing values with the calculated mean. This is a calculated mean. Okay, that's the calculated mean here, and put it in place true. Okay, that's what it means here. Replace it mean with to fill the data here with the mean values here. And then we print the data frame. That's new data frame here, you see here. Okay, we will be applying this more and more in the future. So it's going to be very, very, very easy for you guys. Okay, we have been through this, replace NA, which is not available, impute, drop rows and drop columns, etc. So we have to be very careful here. It's a lot easier to drop rows than to drop columns. Okay, it depends on the column. We cannot drop the whole columns here because of the. I'm going to show you something here. Where is it? No, not where is it? Something is missing here. Let me show it to you guys. We cannot drop the column, the whole column. Okay, especially this one here, H. Okay, you have 167 missing. So we're going to replace 167 missing by maybe the mean. Okay, or maybe F field or B field. Okay, cabin, we don't need it. We don't need it anyway. Okay, the ticket, we don't need it. So this one doesn't matter if it's the whole cabin is missing. Okay, so we have to be very careful here. And data cleaning and profiling, we have been through this, counting the missing values, counting the invalid values. We can do some statistical descriptive statistics here to see the data in bean frequency. We can go back to the bean. For instance, we have age here, and mean, median, maximum, minimum for the continuous variables bean frequency. You can have like a plot like this, and you can have this one here and this one here, this one here. This is between 5 and 20. This one 20 and 30. That's called the bean. This one is the bean here for a continuous variable. This is continuous variables here. But here we're going to have categorical variables. So we're going to have category frequencies. Like for instance, we're going to have something like this, something like this. They're quite different here. That's a bar plot. That's a histogram. That's a histogram. That's a bar plot here. Okay, and this one is going to be red. This one is going to be blue, etc. And that's categorical. Categorical, and this one is numerical. And that's called exactly, that's histogram here. And that's called a bar plot here. Okay. This is not very important at this stage here. We need to understand the accuracy of the data, reliability of the data, relevance of the data values, and the missing, etc. That's again, it's again part of the ETA. So we can assess the data quality with Python. Okay, for instance, df head is going to show you exactly this one. It's going to show you the top, the 5 top by default is going to show you the 5 top data. Okay, if I go back to this, okay, if you write df, that's the titling data, df head, between brackets here, is going to show me only this, 5. Now, if I put df10, it's going to show me up to 10 here. Okay, up to 10 here. Okay, guys, keep this in mind. Next one is going to be head and rows. How many rows do you want to see? You want to see 7 rows, whatever. Yeah, only the df, which is null. We don't have any values. And what's the sum of all these? How many null values do you have in your column? The correlation here, it's the correlation between your features, not the target. The target is predicted, what you're going to predict. And this one is like the age, sex, all of them. Okay, that's a minimum value in the column. That's the maximum value of the column here. You count here how many values do you have. You describe here. It's very important. The describe is going to be the descriptive stat. Which you remember, descriptive stats, guys. If I go back here, you're going to see it where 1 second. We're going to see it somewhere here, descriptive stat. Yeah, that's a descriptive stat here. That's descriptive statistics here. That's why you can use df, whatever, df1 dot describe between brackets here. And you're going to see all the statistics here, from the count to the mean to the maximum, etc. Okay, so keep this one in mind. This could be very handy, especially in your case. The more you implement it, the more it's going to be a lot easier for you. And I can guarantee you, it's going to be very easy. Okay, I will show you all the tricks you can do. Especially the best way to learn is to do examples. I will have a surprise for you guys. We're going to see a lot of examples. It could be a labs, or it could be, for instance, labs with solutions, of course, or it could be like use cases. All right. So, and another case, we have the outliers. Sometimes you have the outliers. The outliers I mentioned earlier, something 200, age 200 is an outlier. Okay, and you can detect how to detect the outlier. You can detect them by a box plot, you can detect them by a scatter plot, or you can detect them by a value called the z-score. Okay, when you have here the z-score here and you calculate the standard deviation, and you can see the standard deviation is over 3 times standard deviation, this is an outlier. Okay, and then let me see the next one. Yeah, I'm going to see the next one. Okay, then the next one is going to be the box plot and the scatter plot. Once you plot something, you have a scatter plot here. Okay, you can see this one. There is a trend, but somewhere here there's a dot here. A second here. I'm going to move my height. All right, and you have a scatter plot here, and you have a dot here somewhere. That's an outlier. It's an outlier. Keep in mind, this is an outlier. Okay, this one is exactly the same for the box plot, as I said to you before. If it is once it is beyond these 2 lines, when you have data beyond these 2 lines, and this one is these are outliers too. Okay, we showed you the other day how to calculate the IRQ, which is interquartile range, and then you have the minimum here, Q1 minus 1.5 IRQ. That's the maximum here. If it is beyond these values here, it's an outlier, right? If you okay, if it's an outlier. Okay, this is some of the plots. We have the scatter plots, for instance. It can be used with continuous. Okay, X and Y. We have the bar plots, can be used with categorical data and continuous data. And that's X, huh? That's X, guys, and that's Y here. And this one has to be continuous. We have the bar plot here. This for categorical data for the X, and continuous here. We have the box plots here. It has to be continuous. This one have to be continuous. This one have to be continuous. All right, guys. The box plot, we finish the box plot here. The same here. We pie chart. This pie chart. I'm sure you guys have done a lot of this with Excel and so on. It is with categorical and continuous data. We have the histogram here. We mentioned this earlier. It can be done with continuous data. Okay. And here's give you some example. I will just leave you guys to read all this, all right? And here we're talking about the correlation here. What does it mean? If you go back a little bit further, backwards, we're gonna see DF correlation, okay? When you see DF correlation here, what does it mean? DF, this is DF, it's the name of the data, that's df.core, okay? And this is an example of iris database, of iris data. You'll be exposed to this iris data a lot. Yeah. And this is iris data. It's a flower. It has some of the shape of the leaves, etc., right? And you can see here, for instance, there's a correlation. This one is going to be equal to 1, y equal to 1, because it's sepal here, and you have the sepal here, and you have the sepal here. Okay, sepal length, that will be 1. Sepal width, 1. Sepal length, etc., etc. This one is going to be 1. It's diagonal. The rest That's our correlation is going to be equal to this. They are the same. So we can take this one instead of looking at the other ones, because this one is the opposite of this, etc., etc. Okay, so the opposite of this, 81 is the opposite of this, etc. So the same value here, what you see is the same value here. So the correlation here, what does it mean here? It means the highest value here is this, 0.96. What does it mean? The petal here, petal width, is highly correlated with petal length. See? Because they intersect here, both of them. Okay? This one, the petal length, is highly correlated with sepal length. Okay? But what can you see here? The correlation here is very weak between this and this. This one, it can be it's negative one. Whether it is negative or positive doesn't matter. What you need to understand here is this value. Is it the right value or not the right value? Okay, is it high or small? What does it mean? Minus here, it means inversely correlated. It means if you try to plot this, y and x, the line is going to be like this. That's negative. The slope is going to be negative. If you're going to plot y and x like this one is positive, this one is positive, so the y is going to be like this. That's a positive one. All right, so keep this in mind. And this is called exactly the Pearson correlation. That's the Pearson correlation. Okay, that's the Pearson correlation here. All right, if we can do the pairwise correlation between all these here, we can do a plot called the Pearson correlation here using the SNS. SNS is the seaborn. Seaborn, we have to import seaborn as SNS. We'll talk about this before. We'll talk about this later on. And then we plot it. We do a pair plot. Can you see here the pair plot? And this one is a pair plot. Okay, guys, this one is a pair plot. Okay, you can see the pair plot here. There's a correlation between this and this. And you can see here, there's to some extent linearity here. Here, it's bad. It's going to be like this. It depends on the values here. Okay, we'll do this in detail later on. Okay, so this is exactly the pair plot, how to plot a pair plot. I'm going to show you later on in visualization how to plot it. This is two-dimensional data. Scatter plot we can do, line plot, bar chart, stacked area, etc. Okay. This is a three-dimensional. We can do that too. We have x1, x2. We have here x1. We have here x2, and here we have y. And this is for multivariate. Okay, this one is for univariate. That's x and y. Okay, one dimension. This is going to be a three-dimensional style. Okay, we can plot this. In a scatter plot, we can plot it into a y-frame plot, surface plot, it depends. Okay, and this is exactly this. It's a pair plot like this one, but in color. Okay, if you want more of this, you can click on this. It's going to provide you with a plot like this. Okay, so this one is exactly the pair plot here. All right, so here's sepal length, and here you're going to have a sepal length. See that? You see that? And this one here, and this one here is where the 1 are. 1, 1, 1, 1. That shows you the distribution of the data. Okay, and here it's the correlation between the two different data. This is the same data. We have this, and this is correlation between this data and this data, for instance. Okay, that's one here, that's one here. See, You can see there's no correlation really. Yeah, this one is quite good. You can have a plot here. You can have a line here. This one is quite good. You have a line here. This one is quite good. It's the opposite. All right. So adding calls allows certification by a categorical variable, usually called a class. Okay, very important. Here, it's something else. It's nearly the same as df correlation, but we call this heat map. Okay, in the correlation here, you don't see any plot like this. Okay, that's a correlation. It's plain, but if you plot the heat map, we're going to see how to do that. We will apply something like this. As I mentioned earlier, this is again a correlation, present correlation here, the same, exactly the same. The half here is going to be the same like the half here. So we can plot half, or we can plot the whole thing. Okay. And this is a correlation between, in this case, 0.42, and this one is here and here. You can see a strong correlation, for instance, between these, inversely correlated between this and this horsepower. Okay, so we discuss about all these later on. We have to categorical data. We can do that. Statistical of discrete distribution, exploring, visualizing sample data, using bar plot, pie plot, etc., using the auto detection and so on. And at the end of the day now, guys, it's we're gonna have like labs. Okay, we'll have labs and we're gonna have use cases. Okay, now to get to this, I'm gonna send you the link. And if you have any problem, some of the data are not available. Some of the data is not available. The data will be covering. So please mention them in the comments so I can upload them. Okay, you will be accessing all these use cases and the labs here. Okay, so this one is only you have the Titanic CSV data, but the rest you have lab 1, you have lab 2, and you have this book, which is ChatGPT. It's a gift. Okay, to learn ChatGPT, and you have another book which is Python for data analysis, data wrangling with pandas, etc., etc. Okay, you have I give you a giveaway 2 books for you guys to start to get a ball rolling. At the same time, I'm giving you all these data. Okay. So now, if you have any question, please let me know. If you have any question, please go to the comment down here, and then you can ask any question you want, and I'm gonna come back to you guys. All right, I'm gonna come back to you. Now, see you then. And next time we'll be covering some of the, not most, but some of the use cases and 1 or 2 labs, right? We have all the solutions here. I'm gonna upload everything here, and hopefully you're gonna I will show you the way how to deal with the real ETA. Okay, thank you very much, guys, and see you around. Take care.